Hi, everybody. My name is Michal Schwartz. I'm professor of neuroimmunology at the Weizmann Institute of Science, Department of Neurobiology. My goal today is to share with you latest advances in searching for therapy for Alzheimer's and dementia. I don't need to discuss with you that this is a devastating disease. However, I would like to share with you some features of the disease. Only 5 to 10% of the cases are genetic cases, inherited disease. The rest are sporadic. It's mainly age-related. The disease is quite heterogeneous among patients. The disease is very dynamic, multifaceted, and multifactorial. We know that it is associated with neuronal loss, synaptic loss, accumulation of waste in the form of plaques and tangles, associated with local inflammation. Numerous attempts were done in the past since the disease was first discovered in 1905 to find a cure. Most attempts were directed to prevent accumulation of plaques or facilitating their removal. In addition, there were attempts to reduce the inflammation. All of them have fallen short. In 2018, the editor of Nature Medicine invited 4 scientists worldwide to share with the editors what they, in their view, the most promising way to treat Alzheimer's or to fight against Alzheimer's. One of which was our approach, which is unique. It's a dogma-breaking approach that has never been tested before, never been proposed before. So basically, our treatment is not directed to the brain, it's directed to the immune system. So basically, what we are proposing, that by activating the immune system, we are facilitating mobilization of immune cells to the brain. And these immune cells that are coming all the way to the brain can facilitate removal of waste and reducing the local inflammation. It's not based on finding by serendipity. It's not based by trial and error. It's based on more than 20 years of study by my team. We started in 1998 against the dogma at that time when we discovered that immune cells can help recovering following spinal cord injury or head trauma. Subsequently, step by step, we built by deciphering the underlying mechanism, we came all the way 2016 to propose immune therapy to Alzheimer's. So what is special about the immune system? Why in the context of the brain? We know that the immune cells are the major cells that patrol the body to recognize any microorganism that invade the body and to make sure to remove them, such as bacteria and viruses, before they are causing any infection. The role of the immune system, we know now also to destroy malignant cells before the tumor develops. It's the major system that helps curing any tissue following sterile injury. But the brain was believed for many years as a tissue that escaped from any immune help because of the blood-brain barrier. And therefore, it was believed that any immune activity in the brain is a sign of pathology that should be suppressed. And this was the belief for decades. My team in 1998 asked for the first time, maybe we are wrong. We know that the brain is the only tissue in the body that we know that we'll never be able to replace. So we thought that it doesn't make sense that the tissue that is non-replaceable and it's so precious has given up the opportunity to be assisted by the immune system. And we discovered that this is not the case. The brain needs the immune system for its help. And we found that the immune system is supporting healthy brain plasticity. We found that the immune system helps formation of new neurons in the brain. We found that the immune system helps us to cope with stress. And lately, one of my former graduate students also discovered that the immune system will support our social behavior. So overall, although the immune system is not part of the neuronal network in the brain, we need it for lifelong brain support. And we coined the idea that maybe aging of the brain reflects more aging of the immune system rather than chronological aging. With this new understanding, the immune system helps supporting the brain and supporting help of the brain, repairing the brain, we are searching to see where is the site of communication between the brain and the immune system. We knew that the blood-brain barrier is definitely not a permissive site of communication. And what we discovered that there is interface between the brain and the immune system that allow communication. And this is the blood-cerebrospinal fluid barrier, the barrier between the liquid in which the brain is floating and the blood vessels. So basically what we discovered that there is any injury in the central nervous system, including in the spinal cord, by studying how it works, we realized that under any pathological condition, such as the case of Alzheimer and dementia, there is an SOS signaling coming from the brain and said, we need help. This SOS signaling, together with the immune system, help repairing the brain. So based on this, we envisioned that maybe the communication between the brain and the immune system is not optimal under aging and Alzheimer. Over the years, since we first published that macrophages or immune cells are helping the brain, there were numerous studies in Israel, by my team, in Europe, in the States, and in Canada, showing that if you boost the number of immune cells that comes to the brain, you can reduce disease pathology. So based on this, we decided that maybe the best way to treat Alzheimer, rather than trying to remove the waste directly, to activate the immune system to facilitate mobilization of immune cells to the brain, and they may contain all the accumulation of the waste and the local inflammation. To do this, we are using a mouse model that carry genes that are defective in human and cause in the animal model all symptoms of Alzheimer and dementia, including symptoms of cognitive impairment, accumulation of plaque, local inflammation. Here you can see two types of maze that we are frequently using to assess the treatment effect in animal model of Alzheimer and dementia. At the bottom left side, you can see T maze, and this is a maze in T shape. And when you introduce the animal first to the T maze, you keep one arm closed, and the animal are habituated and learn the maze. If they learn and remember, when you open this arm, they will have preference to this arm. At the top left side, you can see bars, and the red bars show you preference of healthy animal. On the right side, in black, you see no preference of sick animal. Another maze that we are using is what you see in the middle bottom part of this slide. And this is a pool of water in which there is a platform. The animal, when you first introduce the animal to this maze, they don't need to see the platform, but if they step on the platform, they look around and they can recognize the position of the platform relative to picture around the pool. So on the right side bottom, you can see a learning curve of healthy animal. These are the black curve. And you can see that the number of errors that the animal are making before they enter into the right arm of the maze is reducing with the experience. So they learn and remember. The red shows you Alzheimer animal, no learning and no memory, of course. So using this maze, an animal model that carry genes that are defective in human, we can see that our treatment is able to overcome cognitive loss. On the left side, you see animal with dementia. You can see the gray bar and the blue bar. The gray bar, on the left, you can show preference to the novel arm of a healthy animal, and the blue show you a preference of sick animal that was treated by our treatment, which boosts the immune system. To make a long story short, I just want to let you know that we tested our therapy in different mouse models that carry different genetic mutation, which means that we are able to overcome disease heterogeneity. And we found that in all the animal models, we improve cognitive ability, basically arrest cognitive decline, and we reduce disease pathology. We also showed that all animal models, we rescue neurons, which means that the rescue of neurons is, we can attribute the improvement in cognitive ability, at least in part, to rescue of neurons. In addition, we see in all animal models that we are tested, we reduce the local inflammation. So overall, what's the difference between our treatment and current attempts that were made? So in the ideal world, you would like to identify all the factors that contribute to disease escalation and neutralize one by one and create a therapy which will be a combination of therapy. This is very difficult to achieve. our approach, by single therapy that is directed to the immune system, we are facilitating mobilization of immune cells to the brain, and these cells can contain multiple factors, including reduction of pathology, reduction of inflammation, rescue neurons, and altogether leading to cognitive improvement. So in summary, we developed a new therapy which activates the immune system and age-related dementia. This therapy overcomes disease heterogeneity. We found that it reduced the multiple factors that associate with disease escalation. We found that we can treat at an early stage of the disease, but also when the disease is full-blown, given that in patients, the disease is manifested after a long period of being dormant. It's a big advantage that we can treat when the disease is full-blown. Based on the understanding of the mechanism, we developed a new antibody that is different from the antibody currently used in cancer, which is the immunotherapy for cancer. This new antibody has a safety profile which is superior to any of the antibody currently used in cancer while maintaining still efficacy. Since it's a chronic disease, we developed an approach that we will be able to continuously treat the patient. In animal, we found out that we can give every 6 weeks. Based on numerous studies done in animal and in monkeys, and developing a model of translation, we anticipate that in patient it will be given every 3 months. So I will give you the flavor of the underlying mechanism. So as I told you in the very beginning, in human and in mice, with aging and with the disease, the immune system becomes exhausted. The immune system is suppressed. The treatment is basically alleviating the immune system from the suppression. Thereby, we activate the immune cells. These newly activated immune cells can activate the gateway to Alzheimer's, which is not permissive for entry. So the immune cells that we are releasing from suppression, holding the key to the gate. As a result of it, we are allowing or facilitating mobilization of new immune cells to the brain. These immune cells are very unique because they can remove very effectively those accumulation of misfolded protein that are toxic to the neurons. And thereby, we can arrest the fire, which is arresting the inflammation and facilitating cognitive improvement. Overall, it's a first of its kind immunotherapy. By reviving the immune system, we can help curing the brain. It's not total cure because the disease is chronic, but it's turning currently a disease which is not curable into believe it will be turning the disease into a chronic treatable disease. So the license to develop our technology to treatment for Alzheimer's disease was given to a company, Immunobrain Checkpoint, together with strategic and financial partners. The company developed the new antibody and made it all the way to the clinical trial. By the way, we got support from Bill Gates Foundation to support the clinical trial. My own research at the Weizmann Institute was heavily supported by competitive grants, including the European grants, and also by private foundation like Adelis and Thompson, without which we will not be able to do this work. And of course, without outstanding student, current student, and postdoc, past student and postdoc, some of them are now independent investigators in Israel, in the States, in Europe, and in Australia, and many collaborators, great collaborators in Israel and abroad. This gives you the feeling what it means to go from curiosity-driven research all the way to the clinic. So it means that we are going up and down, up and down. It takes many years. And when you reach the top, it's only at the beginning. It's not at the end. Thank you.